What's up, everybody? This is a video about 4.1. Welcome to the unit about square roots. All right, so before we enter into the land of square roots, I want to make sure we can solve for x with a trinomial, such as this. You may factor, or you may just plug it into a calculator and notice where the x-intercepts are. So if you want to do the by hand way, like I'll do for number 2, I want to find the factors of negative 28 that add up to negative 3. That is negative 7 and 4. They multiply to become negative 28, but they add up to become negative 3. So that means the factors of this would be a minus 7 times a plus 4. And so that means you would get two answers. You get the answer of negative 4 and 7 as the possible values of a. That is one way to do it. The other way would be to you change the variable to an x like this. And then you would notice that when you do this, it makes a parabola, like so. And the two x-intercepts from the parabola are 7 and negative 4. And notice those are the exact same answers I got. Yeah, that'd be cool. All right. So the challenge problem is basically the same thing. Just got to subtract 7 first and divide by 2, and then you'll notice it's the same type of problem. Actually, no, I'm sorry, you don't subtract 2. You add 57 to both sides, and then you can just divide by 2, and then it's really the same type of problem as 1 and 2. All right, so welcome to the unit about square roots. You're going to get asked stuff about, so here's things that you're going to see a lot. The plus minus symbol, that is when you see a plus sign and a minus symbol below it. This means that the positive or negative values of a number are possible, meaning like if you see this and a 5, that means it could be negative 5 or it could be positive 5. That's what it means. We're going to be squaring stuff. We're really not going to be squaring stuff, but you're going to see a lot of things to the power of 2 very often. And that means what is something times itself. And for example, 5 to the power of 2, or in other words, 5 squared means 5 times 5, and that's 25. Now, this whole unit is going to be about square roots, and that's when you see this symbol right here, which basically what that symbol is asking is what number times itself makes the number inside of the square root. For example, the square root of 25 is positive or negative 5, meaning it's not just 5, it could also be negative 5, because negative 5 times negative 5 is also 25. So there's very often going to be two answers to really every problem today, really. Okay, so the first thing is solving for a variable being squared. Before we enter into what's called completing the square, we got to be able to do things like this. Okay, so number one is like something that happens sometimes, like my move numbers and things around to leave the thing being squared is by itself on one side of the equation. By itself on one side of the equation. So meaning like, all right, these first two examples, you don't have to do it. You don't have to do step 1. Okay, like there's nothing else on the same side of the equal sign as what's being squared. But over here, this one and this one, yes, like you would have to, for example, for this one, you would subtract 3 first. This one you divide by 2 first, because you need to make it just thing being squared, isolated on one side of the equal sign. Yeah. All right. So then after that, after you've isolated it, you do the square root of both sides. So if you square root both sides, all right, square rooting something that is squared kind of cancels it out. Meaning like if you have like if I want to square root what is x squared, it just becomes x. Okay, it just becomes x, right? But then you have to also square root 49. And square root of 49 is not just positive 7, but it's also negative 7. So like the answer for this would be plus minus 7. So this would be like x equals plus minus 7. That's what that would be. Now, as for like these types of problems, this probably requires a little bit more to it. So for example, this one. All right, so x minus 7 squared equals 16. what you do is you would square root both sides. And when you square root both sides, the left side is just x minus 7. It is. And then the other side becomes positive and negative 4, meaning it's not just 16, not just 4, it's positive and negative 4. And then you would have to add the 7 to both sides because we wanted to make it say x equals. So if you add 7 to both sides, you now have positive and negative 4 plus 7. Okay, so what does that mean? Well, that means two things. That means 4 plus 7, which is 11. It also means negative 4 plus 7, which equals 3. So this is why the answer to this would be 3 and 11. Like, that is what that is. Yeah. So you're going to get two answers out of this. You're going to get two answers out of this because positive and negative makes it two things. Like it is two things. Okay. Now, as for here, I'm not going to do this one, but as for this one, all right, you would subtract 3 from both sides. You then get x plus 2 squared equals 64. All right, now you would square root both sides, and by square rooting both sides, you get x plus 2 equals positive and negative 8. Okay, and again, so you now subtract 2 from both sides. That means x is positive or negative 8 minus 2, which means two things. That means 8 minus 2, which is 6, and that also means negative 8 minus 2, which is negative 10. So that creates two answers. That means x is negative 10, and it also means 6. And that's the answers to this. So that's how you do it. That's also how you do, like, the last examples. You just divide everything by 2. Okay, so, like, I'm not going to do the whole thing for you, but, you know, it's if you divide both sides by 2, you then get x minus 3 squared equals 9. And then you would square root both sides. You get, so that one turns into, you should get two answers. You get 0 and 6, actually, from that. Yeah. And that's how you do that. And that's how you do these. All right, now let's complete the square. Okay, what the heck is completing the square? Well, the warm-ups looked kind of like this example question here. Like this question, like x squared minus 6x minus 5 equals 0. The problem with this is there are no factors of negative 5 that add up to negative 6. There are none. And when that happens, we can still have x-intercepts. We can still have that, but they're going to be decimals. And so I need to kind of show you how to do what's called make a trinomial into a perfect square. And that actually allows us to solve for this by hand. I mean, yes, we can just put this in Desmos and see decimals, but you should also be aware about how to do it without that shortcut, really. Okay, so all right, so here's an example here of how to do this problem, but I'm going to show you how to do this problem. All right, first thing is I want to get rid of that 5. I want to make the 5 kind of go to the upper side, so I'd add 5 to both sides. All right, so by adding 5 to both sides, that creates, so you just want to have the ax squared thing and the bx thing, and there is no c value. Instead, it goes to the other side of the equal sign, like that. And then the next thing is, if you, all right, there's a formula that's written right here, and this is what you would be adding to both sides to create what's called a perfect square trinomial. The formula is b over 2, what is it? I can't, squared. All right, so that's the formula that you would add to both sides of the equation to give us a perfect square trinomial. So the b value in this problem is negative 6. So that would be negative 6 over 2 squared. And that means I would be adding 9 to both sides, okay? Because this turns into -3, and then -3 squared is 9. It is 9, so I'd be adding 9 to both sides. So the next step is I would be adding 9 to both sides. Okay, so that is minus 6x plus 9 equals, all right, 5 plus 9 is 14. Okay. Now, over here, this is a perfect square trinomial because the factors of 9 that add up to -6 are -3 and -3. So that means that this would be x minus 3 times x minus 3. And what that really is, notice they're both the exact same thing. So really the next step to this would look like this. Since x minus 3 times x minus 3 are the same thing, you get x minus 3 squared equals 14. Okay, so now the problem looks like the stuff we did earlier. What do we do now? Well, now we would square root both sides. Now, the thing is with this, we're going to get the square roots of numbers that don't have perfect answers. And so 3.7. Today we're just round to the nearest tenth. Okay, so that's, if I square root both sides, I get this. X minus 3 equals plus or minus 3.7. Yeah, so it's not just 3.7, it's also plus a negative 3.7. And so now that means we get two answers. We get, is it 3.7 minus 3, which is 0.7. And we also get negative 3.7 minus 3, which is negative 6.7, and that leads to x having two answers, being negative 6.7 and 0.7. That's how you do this. It is. Yeah, that's the whole process. I'll do this one more time, yet I don't have a lot of time. All right. So for these first 6 questions, you don't have to do the entire process, okay? These first 6 questions are just like, can you do the b over 2 part? Meaning, okay, you're going to take the b value. So find the value of c that makes each trinomial a perfect square round to the nearest tenth. Actually, there's no round to the nearest tenth for these types of problems. That's in the next type. Yeah, round to the nearest tenth. Perfect. All right. So what you do for these problems is you take the b value, like for example, so again, what it's asking you to do is to use this formula, and basically it's just asking, what would you make c? And you make c whatever this turns into. And you make c via, well, what is b? b is negative 24. So that's negative 24 over 2, and then squared. So the c value would be 144, because that's what happens when you put in the b value into this formula. You'd be adding 144 to both sides. Yeah. Like, and also for number 18, okay, so like number 18, the b value is negative 1. And that is actually what you would be adding to both sides, which is weird. But true, strangely. Or like for 16, you'd be adding 2.25 to both sides. Strange, but that is true. Now, as for these are like what we have been doing. All right. For example, like number 19, you would be, you add the 20, get rid of the 20 from both sides. You would get x squared minus 14x equals 20. You would then be adding what to both sides? Negative 14 over 2 power of 2. You'd be adding 49 to both sides. So you add 49 to both sides. And then that creates x squared minus 14x plus 49 equals 69. You would square root both sides, and then it would be like x minus 7 squared. So I'm running out of time, so I can't do all of this for you. Equals the square root of 69. Then you would add 7 to both values of that. Sorry I ran out of time. I hope this is helpful. Have a good day.